give you a little time, and I want you to make sure that you get this written down and put it into your little books. Now, one of the ideas in here is all triangles have 180 degrees. This is something that you know, and you instinctively deal with this when you see a picture of a triangle. So when you're working on something like this, make sure that you take the time and draw yourself out a triangle. It doesn't have to be perfect, it just has to represent the situation. So it says, in the right triangle, A, B, and C. B is equal to 35 degrees. The right angle is at vertex A, and find the measure of C. Make sure that you take the time to read through it. Otherwise, what generally happens is people, oh, we're going to make a right triangle. Okay, so they make the right triangle. They don't put the vertices in the right spots, so that ends up causing a little bit more of a problem. So, B is 35, the right angle is at vertex A, so that's A. That's B, which is 35 degrees, and so this has to be C down here. So what is it? 180 minus 90 gives me 90. Now, one of the things that's easier to deal with is whenever you have a right triangle, you really only have to worry about the 90-degree part. So 90 degree, that comes off right away, and I got 90 left. Subtract off 35, and I'm left with 55 degrees, correct? No, that's all that this is 55 degrees. So what's that? Now, I'm going to give you some more time and make sure that you get everything in the box here and get all these corollaries written down. Now these corollaries, what they do is they just really extend out what the theorem is, as well as identify other implications of the statement. Like two angles of one triangle are congruent to two angles of another, the third angles are congruent. That's transitivity. The acute angles of a right triangle are complementary. Well, they have to add up to 90 degrees. Measure of each angle in an equiangular triangle is 60 degrees. So the nice thing is, if you see that you've got a triangle with two 60-degree angles, you automatically know the last one is 60. Okay? And a triangle can't have at most one right or one obtuse triangle. Just the way it is. So, if I am looking at something like this here, find the measure of angle D. Well, I already know that it's a right triangle. I already know the right triangle is 90 degrees, so I got how many degrees left to work with? 90. So I could take 90, subtract off the 58 degrees, and I'm left with 32 degrees. And do make sure that when you're listing the degree measure, you put down degree. Yes, ma'am. This one is 18. So, right triangle. Do I have a right triangle drawn out? No. Does it matter what it exactly looks like? No. Just as long as when you draw it out, you've got it as a right triangle. So I got a right triangle down there. Now it says K and L are the same. So is it possible for either K or L to be a 90-degree angle? No way. It doesn't work that way. So that means that this must be M, correct? So that's got to be K or L. That's got to be K. It really doesn't matter what they are. So again, I had that 90 degrees. So that means I've got 90 degrees left to work with. K and L are exactly the same. So what should I do with 90 to figure them out? Divide by 2. Because they're exactly the same, and I end up with 45. Easy enough, right? If you got a right angle in any triangle, and two angles, the other two angles have to be the same, 45, 45. So, give you a moment and get this one taken out. All right. So as we continue on with this one, we're going to be using the ideas that we've got with that to help us out. Now, there are two things that we're going to see in here that kind of go together with this. Now, it says for XYZ, determine the measure of angle W, Y, Z. Now, normally what you guys would do is you'd say, hey, I know that there's 180 degrees in a triangle. Is this correct? So if I've got 180, I subtract, whoops, sorry, terrible. I subtract off 50, and I'm left with 130. I subtract off 70, and I am left with 60, correct? So that means this would be a 60-degree angle. Now, how many degrees are in a straight angle? 180 degrees. So if I were to go and take 180 degrees, subtract off 60, I am left with 120. So this has to be 120. Now, hold it a second. How many degrees are in a triangle? If there's 180 degrees in a triangle, that's 60. These add up to 120, correct? So what this theorem is telling us, that if I have these two angles here, this angle here and this angle here are going to add up to be exactly the same. That's what that tells us. So when I'm looking at this and it says the exterior angle is equal to the sum of the measures of its two remote interior angles, what it's saying is this one out here is equal to the other two angles in a triangle. So if I look at B down here, I could say, well, gee, that's 48 degrees. I could subtract that from 180 and I could find this one. Then I could subtract that from 180, get a number, subtract 32 off of it, and I'd be left with that, right? But the rule tells me that angle Q and angle P add up to 48 degrees, right? So all I would have to do is take 48 degrees, subtract off 32 degrees, and I'm left with 16 degrees. So that means that angle P up here is 16 degrees. So granted, you can go through and do it the other way. This is just a quicker and easier way of doing it. It's kind of like a shortcut. If you like doing it the long way, by all means, you can do it the long way. But if you got a shortcut, why not take a shortcut? So what I'm going to do here is I'm going to give you a little time, and I want you to go through and do this. Okay? So okay, so we need to figure this one out. Jason, what do you got? Nothing. Why not? First offhand, do you know what the measure of A is inside the triangle? How many degrees are in a triangle again? So I got 180. So if I got 37 here, I'm going to subtract off 37. And so that leaves me with, oh, what would that leave me with? 133. Then I'd subtract off 28, and that would leave me with what? 105? So that means this one here could be 105 degrees, correct? Now, how many degrees are in a straight angle? 180. So if I had 180 and I took off my 105, that means this would be 75 degrees right in here, correct? Now, if I remember, there was a rule that we had that said that if I take this one here and this one here and add them up, it's the same as this here, right? So if I go and take 37 plus 28, I end up with how many fives? 65. Ooh, we got a bit of a problem there. Who subtracted wrong? I did? Oh, that should be 115. Gotcha. So if this is that, that. So, okay. So that means this should be 115, 115, 65, 65. Now it works out correctly. So, see what happens when you go through and do a lengthy calculation. You make an error in there, and even though you know what you're doing, and you're doing things correctly, sometimes following those shortcuts, those rules that they give you make life a lot easier. Less opportunity to make an error. So, let's see. Let's move on to the next one here, and I'll give you a little time to do that. Make sure you do E and F, so give you a little extra time on that. Okay, so let's see what's what. Nice. So we got to make a sketch of this, right? So what kind of a triangle do you want me to draw up? All right. So hi. Okay. So what do you figure that the measures of the base angles are? Okay. So I'm going to draw it out and see what we got here. It says a planned glass pyramid structure has four triangular faces. The angles at the base of each face are congruent. So I know it's got to be something like this, where that and that are going to be the same. Okay. Now they tell me the apex 68 degrees, so that's got to be up here. So if I take 180, subtract off 68, I'm left with 112, correct? Since those have to be the same, I divide by 2 and I end up with 56 degrees. Excellent.